Dear students, in this module we are going to discuss about inheritance concept in Python. Inheritance is one of the most important aspects of object oriented programming. In programming, many a times situations arise where we have to write a few classes with some common features and some unique class specific features which include both variables and methods. In such situations, as per object oriented programming, we can take out the common part and put it in a separate class and make all the other classes inherit this class to use its methods and variables, hence reducing rewriting the common features in every class again and again. The class which inherits another class is generally known as the child class or derived class, while the class which is inherited by other classes is called as the base class or parent class. Inheritance enables us to define a class that takes all the functionality from parent class and allows us to add more. Inheritance provides code reusability to the program because we can use an existing class to create a new class instead of creating it from scratch. There are three ways a parent and a child class can interact with each other. These are: anything did to the child class simply an action on the parent class. Actions done on child class overrides the actions done on parent class. Anything done on the child class alters the action done in the parent class. The benefits of inheritance are: it represents real world relationships well, less code repetition as the code which is common can be placed in the parent class, hence making it available to all the child classes. Structured code: by dividing the code into classes, we can structure our software better by dividing the functionality into classes. Make the code more scalable. It provides reusability of your code. We do not have to write the same code again and again. Also, it allows us to add more features to a class without modifying it. It is transitive in nature, which means that if class B inherits from class A, then all the subclasses of B would automatically inherit from class A. Of course, you must only use this for the related classes only. For example, you can define a class living organism with all the basic features of a living organism defined in it, like breathe, eat, etc. Now, this class can easily be reused by another class animals and human beings, as both of these shares the features. Also, at times inheritance is used to simplify big classes with a lot of variables and methods into smaller classes by breaking down the functionality into core features and secondary features. The core features are generally kept in the parent class. Now, let us see some of the Python inheritance terminologies like superclass, the class from which attributes and methods will be inherited. Superclasses are sometimes called ancestors as well. Subclass, the class which inherits the members from superclass. Method overloading, redefining the definitions of methods in subclass which was already defined in superclass. Now, let us see the syntax of inheritance. Class, base class, colon, body of base class, derived class of base class, colon, body of derived class. Here, in the base class functionalities will be specified In the derived class, the derived class functionality will be specified, but through derived class we can access the functionalities of base class as well by including the base class name inside the parenthesis in the derived class. If we have a class parent and another class child and we want the class child to inherit the class parent, then in parent class, the class name is parent. So, class parent, A is initialized with 10, B is initialized with 100, and do this, do that. Two functions are defined with the help of def keyword, and inside the child class, the parent is inherited by using the syntax called class child of parent. Here, the x value is initialized to 1000, y value is initialized to -1, and here also two other functionalities, do what and do not do that. Two functionalities are defined. So, by using this particular derived class, we can access the base class variables A and B as well as the base class functions do this, do that in a derived class. By specifying another class's name in parenthesis while declaring a class, we can specify the inheritance. What we discussed in the particular example, all the properties of parent will be inherited to the child class. With this, all the methods and variables defined in the class parent becomes part of child class too. Derived class inherits features from the base class, adding new features to it. This results into reusability of code. Classes can inherit from other classes. There exists a hierarchy relationship between classes. It is similar to relationships or categorizations that we know from real life. Think about vehicles. For example, bikes, cars, buses and trucks are vehicles. Vans, sports cars, convertibles and estate cars are all cars, and by being cars they are vehicles as well. We could implement a vehicle class in Python which might have methods like accelerate and brake. Cars, buses and trucks and bikes can be implemented as subclasses which will inherit these methods from vehicle. For example, if the vehicle is the parent class, then cars, buses and trucks are the derived classes which have inherited all the features of parent class vehicle with many more additional features as well. Let us take simple example. Animals can be divided into multiple types like reptiles, mammals, amphibians, etc. While they are all different physically and biologically, there are many characteristics that are common amongst them. So, now we will define a parent class with the name animal which will have some basic properties and functions related to animals, and then we will define classes for various other types, and all those classes will also inherit the class animal. Here we have the animal class. Class animal, the properties are multicellular, that is set to true, and eukaryotic, that means cells with nucleus, is also called as eukaryotic. So, this particular property is set to true. The functions are breathe and feed. Now, let us define a class for mammals. As mammals are animals with warm blood who produce milk for their infants, etc. Hence, our mammal class will look like class mammal of animal. So, the base class is animal and it is inherited, that is derived class mammal inherits the base class animal, and the properties of the mammal are have mammary gland true and warm blood is equivalent to true. Functions are produce milk. In case we want to create another class for amphibians too, then class amphibian which inherits the base class called animal, and its own property is live in water, that is set to true, and its own function is metamorphosis. As the classes mammals and amphibian both inherit the class animal, hence they will have the properties and functions defined in the class animal. Hence, now any object of amphibian class, say frog, will have the properties multicellular from class animal, eukaryotic from class animal, live in water from class amphibian, and would be able to breathe, feed and do metamorphosis. And how all this can be written as code if we create an object, say frog. Amphibian frog is equivalent to amphibian function. So, an object name is here frog, then frog dot breathe method calling the function defined in animal class, frog dot metamorphosis calling the function defined in amphibian class. So, now if you display frog dot live in water, the output will be true. Next, let us see how to access parent class element in child class. While working in a child class, at some point you may have to use parent class's properties or functions. In order to access parent class's elements, you can use the dot operator. Parent dot variable name. Mentioned above is, by using this particular syntax, you can access the variable, or in case you need to call the parent class function, then use parent dot function name, where parent is the name of our parent class and variable name and function name method or its variable and function respectively. Let us see an example to demonstrate this. Class parent, here the variable 1 is initialized to 1 and function 1 with self value is passed here. Then class child of parent, here child is the derived class, parent is the base class. In child class, the variable 2 is initialized to 2 and function 2 is defined. Here it has the time to use variable 1 from parent. So, we can declare one more variable called my variable and it is initialized with parent dot variable 1 plus 10 and that my variable value is returned. So, here that parent dot variable 1 value is retrieved from the parent class variable 1, that is the value here is 1. So, 1 is added with 10 and the my variable result will be 11. Till now we learned about inheritance and how a child class can inherit a parent class to utilize its properties and functions. What if a class want to inherit more than one class, or is it possible to inherit a class which already inherits some other class? To answer these questions, let us see the different forms of inheritance. The first form is called as single inheritance. When a child class inherits from only one parent class, it is called as single inheritance. The second form is called multiple inheritance. When a child class inherits from multiple parent classes, it is called as multiple inheritance. Unlike Java and like C++, Python supports multiple inheritance. We specify all parent classes as comma separated list in bracket. Like C++, a class can be derived from more than one base classes in Python. This is called multiple inheritance. In multiple inheritance, the features of all the base classes are inherited into the derived class. The syntax for multiple inheritance is similar to single inheritance. The syntax for multiple inheritance is class base 1 base class name, then set of statements. For example, here I am writing pass, then class base 2, then pass, then class multi derived of base 1 comma base 2. Here the base 1 and base 2 are inherited into the derived class called multi derived. So, more than one base class is there, that is why it is referred to as multiple inheritance. here multi-derived is derived from classes base 1 and base 2. The class multi-derived inherits from both base 1 and base 2. On the other hand, we can also inherit from a derived class. This is called multi-level inheritance. This is third form of inheritance. It can be of any depth in Python. Here we have child and grandchild relationship. In multi-level inheritance, features of the base class and the derived class is inherited into the new derived class. Class base, then set of statements and functions, class derived 1 of base set of statements, then class derived 2 of derived 1, then set of statements. Here the derived 2 class is inherits the properties and methods from derived 1 class, whereas the derived 1 class inherits the properties and methods from base class. Here derived 1 is derived from base and derived 2 is derived from derived 1. In Python, there is a function which helps us to verify whether a particular class is a subclass of another class. That built-in function is subclass of param1, param2, where param1 and param2 can be either class names or classes object name. Class parent, here the variable 1 is initialized to 1 and function 1 will do something, and class child of parent, here variable 2 is initialized to 2 and function 2 will do something, and in a command prompt, if you execute a simple command is subclass of child parent, then the output is true because is subclass checks whether the first argument is a subclass of the second argument. Here the first argument or the first parameter is child. According to this particular program, child is a derived class of parent. Therefore, is subclass function returns true value as a output. Next, let us discuss about method overriding in Python. Method overriding is a concept of object-oriented programming that allows us to change the implementation of a function in the child class that is defined in the parent class. It is the ability of a child class to change the implementation of any method which is already provided by one of its parent class. There are two conditions that must be met for overriding a function. The first one is called inheritance. Function overriding cannot be done within a class. We need to derive a child class from a parent class. The second condition is that the function that is redefined in the child class should have the same signature as in the parent class, that is same number of parameters. As we have already learned about the concept of inheritance, we know that when a child class inherits a parent class, it also gets access to its public and protected variables and methods. For example, class parent, anything is a function, in that it will display function defined in parent class. Then there is a child class called child which inherits the base class called parent and it will do nothing. Then object 2 is equal to child method, object 2 dot anything method. So, here the object 2 is created for the child class, and through that object if you call the function or method which is written in the base class, then the output will be the base class definition. So, for example, here the base class define or the base class specifies that function defined in parent class. So, the output will be function defined in parent class. While the child class can access the parent class methods, it can also provide a new implementation to the parent class methods which is called method overriding. Let us take an example. Consider the parent class named animal, class animal with properties multicellular is equivalent to true, eukaryotic is equivalent to true, breathe function I breathe oxygen, feed function with I eat food. These two are print statements. Let us create a child class herbivorous which will extend the class animal. So, class herbivorous of animal. So, here the herbivorous is a derived class, animal is the base class. Here this herbivorous contains a function called feed, which will display the content called I eat only plants, I am vegetarian. So, in the child class herbivorous, we have overridden the method feed. So, now when we create an object of the class herbivorous and call the method feed, the overridden version will be executed. So, I am going to create an object for the class herbivorous, the object name is Herbie. So, if I call Herbie.feed method and Herbie.breathe method, Herbie.feed method calls the feed method of base class. Okay. So, the base class feed method is I eat food, whereas here we are creating an object for the herbivorous class. Therefore, the method is overridden in the herbivorous class. Therefore, the feed method will display I eat only plants, I am vegetarian. So, when we use the same Herbie object to call the breathe method, the breathe method of the base class is executed and it will display the output as I breathe oxygen. Next, let us discuss about superfunction. With a superfunction, you can gain access to inherited methods that have been overwritten in a class object. When we use the superfunction, we are calling a parent method into the child method to make use of it. For example, we may want to override one aspect of the parent method with certain functionality, but then call the rest of the original parent method to finish the method. In a program that grades students, we may want to have a child class for weighted grade that inherits from the grade parent class. In the child class weighted grade, we may want to override a calculate grade method of the parent class in order to include functionality to calculate a weighted grade, but still keep the rest of the functionality of the original class. By invoking the superfunction, we would be able to achieve this. The superfunction is most commonly used within the init method because that is where you will most likely need to add some uniqueness to the child class and then complete initialization from the parent. Next, we will discuss about access modifiers in Python. In most of the object oriented languages, access modifiers are used to limit the access to the variables and functions of a class. Most of the languages use three types of access modifiers. They are private, public and protected. Just like any other object oriented programming language, access to variables or functions can also be limited in Python using the access modifiers. Python makes the use of underscores to specify the access modifier for a specific data member and member function in a class. Access modifiers play an important role to protect the data from unauthorized access as well as protecting it from getting manipulated. When inheritance is implemented, there is a huge risk for the data to get destroyed due to transfer of unwanted data from the parent class to the child class. Therefore, it is very important to provide the right access modifiers for different data members and member functions depending upon the requirements. Let us move on to different types of access specifiers. There are three types of access modifiers or specifiers for a class in Python. These access modifiers define how the members of the class can be accessed. Of course, any member of your class is accessible inside any member function of that same class. The members declared as public are accessible from outside the class through an object of the class. The members declared as protected are accessible from outside the class, but only in a class derived from it, that is in the child or subclass. These members are only accessible from within the class, no outside access is allowed. Implicit actions occur in Python inheritance when a programmer defines a function in the parent but not in the child. Class super of object, implicit method, inside the method display the content superclass with implicit function. Then another class sub with inheriting the properties of superclass. Here SU is equivalent to super, SB is equivalent to sub, SU dot implicit method, SB dot implicit. That means through SU we call the implicit method of superclass, through subclass object also we can call the implicit method of superclass. So, what will be the output means the first one will display the superclass with implicit function, and the derived class object is also calls the base class implicit function. So, once again the content like superclass with implicit function will be displayed. In this code, both objects of the base class as well as the derived class can invoke the function of the base class. Also, the pass statement under the subclass is used to tell Python that the programmer wants an empty block which is created under subclass, but it says there is nothing new to define in it. This shows that if we put any function in the base class, then all the derived class will also get the features automatically from the base class, that is inherit all the behavior from the parent class. Let me conclude this module. This module went through constructing parent classes and child classes, overriding parent methods and attributes within child classes using the super function, and allowing for child classes to inherit from multiple parent classes. Inheritance in object oriented coding can allow for adherence to DRY, that is don't repeat yourself, principle of software development, allowing for more to be done with less code and repetition. Inheritance also compels programmers to think about how they are designing the programs they are creating to ensure that code is effective and clear. I hope you enjoyed this module. Thank you.